Welcome back to TekkinLife, and today we will be learning more about linear relations and specifically about the lines of equations, also known as y equals mx plus b. So let's get started. Now, as mentioned, the formation of the equation of a straight line is y equals mx plus b. I just want to highlight why I bolded the word straight, and that's because we're talking about linear relations. So we're talking about straight lines, not any curved lines. So this equation is only for straight lines. Now, let's go over what each of these variables in this equation mean. Y is the dependent variable, x is the independent variable. So this means that y depends on x, and x is a variable that changes on its own. It might not make sense right now, but with the example, I'm sure it will. Now, m is the slope, which is the rate of change. So sometimes we see a rate when we hear the words per. What's an example of a place where we hear per? Well, we hear kilometers per hour, for example, when talking about speed. That's an example of a rate, because a dependent variable over an independent variable, which gives you a rate of change. If you want to know more about slope, check out my last video on how to calculate slope. And b is the initial value. This basically means where your line is starting from. So let's check out an example to clarify these four different variables. Here's a simple example. John and his family are going on a road trip. They're driving at a constant rate of 100 kilometers per hour. Write an equation to express how far they would be after h hours. So let's break this down. Let's start with picking out key information that it's given us. Right here, it says that they're driving at a constant rate. Now, what did we say rate represented? M, the slope, the rate of change. So that means they're moving at a constant rate of 100 kilometers per hour. So this is one piece of important information. Second, we're trying to see how far they would be in kilometers after h hours. Now, when they say after h hours, it just means after any random given amount of hours. So this is one important piece of information because we need to find how far they would be in kilometers. So that is one of our variables, something that we do not know. And after h hours is also another variable because it's changing. Now, it doesn't seem like we have an initial value here because it doesn't tell us that John and his family are starting at a specific point. We'll see another example that includes an initial value after. So let's determine what variable is what. To do this, let's look at our two variables. We know this rate right here, 100 kilometers per hour, is our slope. But which variable goes where? Here's what I do. I look whether the first variable would make sense to be dependent on the second, or would it be the other way around? It's just guessing and checking. So would you think that the distance they travel in kilometers is dependent on how many hours they travel for? Or do you think the number of hours they travel for depends on how far they go? I think the distance depends on the time. As we usually see on street signs, we see rates in kilometers per hour. And also, our slope right here, our rate of change, tells us that it's kilometers per hour, which means that kilometers is y and hours is x, because slope is the change in y over the change in x, which you can also see in my past video. So we know that this is the dependent variable, and this is the independent variable. Now, how do we write an equation with this? So, first things first, we need to understand that the letters for the variables do not matter. If it says y here and x here, that doesn't mean that we have to use y and x. They're just there as placeholders, and we can replace them with any variable letter that we want. So, for my y, since I am talking about kilometers and I'm talking about distance, I'm going to say d. Now I put the equal sign, and m is supposed to be filled in with the slope that's given in the question. So that slope is 100. And same thing we did for y goes for x. We can use any variable we want. I'm going to use h, as it says right here, after h hours. That is our x variable. We have our distance is equal to 100 times the number of hours, plus our initial value, which is also supposed to be substituted with a number. So the b value and the m value should be substituted by some kind of number, a hard-coded number. However, as we mentioned earlier, there is no initial value in this question, so we're just going to put 0 for now, which is basically not needed. So our equation ends up as this: d equals 100h. It might not make sense right now, but let's put it into use. So let's say the question was asking, after 3 hours, how far did they travel? So let's say h was equal to 3. Then, what do you think we would do? Well, if we're given a value for our h, then all we need to do is use the equation and substitute in that value. So we have d equals 100 times h, but now we have a value for it, so we can just put in brackets 3, since it's being multiplied. So that means d is equal to 100 times 3. Now we can just evaluate that to 300. And as we said that d is in kilometers, this distance value is actually in kilometers. So this means that after 3 hours, John and his family have traveled 300 kilometers. Here is another example. Suppose that the water level of a river is 34 feet and that it's receding at a rate of 0.5 feet per day. Write an equation for the water level, L, after d days. So, let's highlight the important information. We have the river being at a water level of 34 feet to begin with. Now, when we say to begin with, that is our initial value, because initially the river is 34 feet. So, we're going to label this as b, as it's our initial value. Now let's go on and look for our rate. We see that the river is receding at a rate of 0.5 feet per day. That would be our m value, since we're talking about rate of change. Now it says, write an equation for the water level, L, which is also another important piece of information as it's a variable, after d days. And same reason, this is also a variable, so we need to underline that as well. Now we just need to realize which one is x and y here. So one thing we need to keep in mind is that whenever we have one of our variables in relation to time, it will always be the independent variable. So d is also in relation to time, so that will be our x variable, our independent variable, and that goes for any type of time, whether that's hours, seconds, minutes, days, months, anything like that. That's why when we say kilometers per hour, it's always per hour and not hours per kilometer, because the hours will always be an independent variable. And that leaves us with the water level being our y variable. Now let's start writing out how we will be formatting the equation y equals mx plus b. And now let's just replace each part of this with what we've collected. So our y variable is L, so we're going to put L there, equals. Now here's where it gets a little tricky. Our rate is 0.5 feet per day. However, we need to take into consideration that the water level is receding. Now, does receding mean that it's going up or going down? Receding means to go down, meaning this should be a negative slope. Since the water level is decreasing, we need to represent it by a negative 0.5 rather than a positive 0.5. So, our slope becomes negative 0.5. And then x, this variable right here, which is our d variable in days, now plus our initial value, our b value right here. And our b value is 34 feet, once again, because the river starts at that level. So this right here is our equation. L equals negative 0.5d plus 34. Now just as bonus, let's try to solve this. In how many days will the water level be 26 feet? Now we're trying to find in how many days, so that means that we're not touching our d variable since we don't have a value for it. but it's asking in how many days will the water level be 26 feet. So what variable is keeping track of the water level, which is 26 feet here? Well, that is the L variable, so we're just going to replace L by 26 feet and then solve the equation. So we have L equals negative 0.5 D plus 34. And now we just replace L with 26, since that is the variable keeping track of it, and then we copy the rest of the equation, and then we just solve it. Now if you don't know how to solve equations, go check out one of my older videos on how to rearrange and solve equations. Now we simply solve this, so I'm going to move this 34 over to the other side and make it negative, so that would leave me with 26 minus 34, and that means I get negative 8 on this side, which is equal to negative 0.5 D. Now I'm just going to divide both sides by negative 0.5. And this leaves me with cancellation of the two negatives, and that leaves me with 16 here, which is equal to D. So that means after 16 days, the water level becomes 26 feet. Thank you all for watching. I really hope you enjoyed this lesson. Feel free to leave any questions, comments, suggestions in the comment section. Please like and subscribe. And once again, thanks for watching. I'll see you next time.